Welcome to Caserta's Data Intelligence Series. In this series, we talk about what it takes to go from a good data and analytics leader to a great one. We'll share with you the tools and methodologies you need to build better, faster, and more robust, as well as strategies and frameworks to generate more revenue and grow your business. Featuring some very special guests and experts to inspire you and give you advice and direction on your data journey. And now, introducing your host, Caserta Data and Analytics Evangelist and VP Marketing, Remy Rosenbaum.
Everybody, thank you, and welcome to today's episode in Caserta's Data Intelligence webinar series. And I am your host, Remy Rosenbaum. And today we're going to talk about building powerful data pipelines and transformations in the cloud. How do you extract value from these data and from different sources? How do you make sense of it and transform it and put it into one place so it can be optimized towards your business use cases? So to answer those questions and more, I brought together two excellent presenters that I have today. The first is Robert Picone. Robert's a principal consultant at Caserta, and he's been designing, developing, implementing, and managing solutions in data science, analytics, and data warehousing for more than 17 years. And he holds an MS program in data science from Columbia University. Next up, we have Carrie Graham from Matillion. Carrie is a partner technical success manager at Matillion, and he shows the value of Matillion products and how they can weave and integrate with partners and customers' ETL processes. Carrie is based in Denver. He told me they got a foot of snow last night that blanketed his city. So if there's any connectivity issues, we forgive Denver snow. He has been working with data and applications and programming solutions in the past in mortgage, education, and software industries. Just a little bit of housekeeping, then we'll get started. First, if you have any questions, please, I encourage you, ask them in the questions panel in the right, in the GoToWebinar control panel. And a little bit about Caserta. For those of you who don't already know, Caserta is a data intelligence consulting firm. We help customers extract value from their data through our assessments, roadmaps, robust architectures, and elegant implementations that we do for our customers. We will always do a free conversation first to get started. And if we think that we're good partners, we will definitely talk about next steps in getting your data project on the road. So let's get started. Robert, the stage is all yours.
Thanks, Remy. So let's begin with a very high-level definition of a data pipeline. At its most basic, a data pipeline is a process that takes specified data from a source location and lands it as specified data at a target location. A pipeline could potentially also transform the data such that the input data differs from the output data. They may be chained such that the output of one process becomes the input of another process. They may diverge from a common input, allowing multiple processes to run in parallel from a common input, or pipelines may converge to form a combined output. So what are data pipelines good for? So drilling down a bit into our previous definition, data pipelines bring together disparate data sets, then unify, normalize, and store the synthesized data such that it's optimized towards one or more business use cases. The input data may come from different sources. They may be in different data formats, and they may be transferred using different protocols, different schedules, or different modes. As a unified system, a set of interconnected data pipelines can also manage data dependencies and data quality. So why build data pipelines in the cloud? Well, the alternative is the legacy method, which means building and running them with on-premises infrastructure. Doing this on-prem has a far higher total cost of ownership. Obviously, purchasing the necessary hardware requires significant upfront outlays of cash. You could lease the hardware, but even then, the monthly cost would typically be far larger than a properly sized cloud configuration. Additionally, on-premises infrastructure requires comparatively higher ongoing personnel costs. A great deal of the configuration and maintenance requirements of on-prem infrastructure is eliminated or abstracted away when using a cloud service. Another slam dunk advantage of the cloud is its scalability. With on-prem, your computing and storage resources are capped. Your resource needs may not only grow over time, but even from the very outset, your resource needs may vary greatly hour to hour. And most cloud products are extraordinarily scalable, and you are only charged for what you use. Cloud-based resources typically are easier to integrate with external data resources and even internal resources, especially if those internal resources are siloed. It's generally also much easier to deploy and run cloud infrastructure using best security practices. And just to tie both of these points back to the lower cost of ownership theme, the extent to which doing on-prem integration and security is easy or difficult is a direct function of having a sufficiently skilled on-prem infrastructure expert. So the challenges and roadblocks in the design, implementation, and operation of cloud-based data pipelines are security, access, functionality, usability, scalability, and extendability. A great real-world example of solving these challenges took place in a recent Caserta engagement with Moffitt. This client is a leading cancer research hospital network, and we were tasked with replacing their complex legacy on-prem data infrastructure that was due to be end of life with a streamlined, regulatory compliant cloud-based data ecosystem. So security and access had to be fully compliant with HIPAA and several other applicable regulatory standards. Functionality had to encompass all current and envisioned future use cases specific to cancer research and patient care. It had to have a high degree of usability such that Moffitt's in-house data developers who had little to no prior experience with cloud-based data infrastructure had to take over development and maintenance of the platform on a very tight timeline. The platform had to be sufficiently scalable such that it would incur minimum cloud charges while meeting processing speed requirements for all business needs. And it had to be easily extendable such that the newly trained Moffitt developers.
Principle for security is to build on and implement the well-established, certified, and compliant resources and best practices of your cloud service provider. Use cloud-native tech stacks that are tightly integrated to each other. In other words, products that securely communicate with each other out of the box. There's really no need to reinvent the wheel here. All of the major cloud providers, whether it's AWS, Google, or Microsoft, have solved for generally all security requirements and provide detailed documentation on how to implement them. Just want to stress, though, that you do always want to follow and implement the established best practices. Additionally, major cloud providers can host infrastructure that can be compliant with HIPAA, Sarbanes-Oxley, PCI, and many other common regulatory standards. In the very early days of cloud computing, many of these regulatory standards didn't permit the use of cloud computing, but today that's really a rarity. So this is a diagram that illustrates the data flows that we established for Moffitt with respect to security. We used a tightly integrated stack, specifically Matillion as our ELT platform, Snowflake as our MPP database, and AWS as our cloud services provider. Matillion runs as an instance within the AWS Virtual Private Cloud, or VPC. Snowflake is a cloud-native product running behind its own VPC, which is virtually linked to the AWS VPC using Amazon's private link service. And then Moffitt's corporate network and environment, which is behind its own virtual private network, is linked to the AWS VPC via a VPN tunnel. The corporate VPN is configured such that access to the VPC is only possible from authorized corporate network resources, and the VPCs are not exposed to the public internet. The universal rule for configuring access is to limit access to each discrete resource to the smallest possible subset of users. Cloud infrastructure configuration covers much of the high-level gatekeeper access to each resource, while configuration within the software stack allows for finer-grained permissioning at the group and user level. In our Moffitt example, a Moffitt network login ID is either assigned or not to a group that has rights to the VPC. Matillion has user and group configuration such that each user is granted a subset of rights to data processes, read-only, right to edit, right to run, etc. The Matillion instance has an AWS IAM role on which granular permissioning to each AWS resource is configured. And then within Snowflake, users and groups are configured with database level permissions. In this context, Snowflake users can be individual developers or Matillion itself. Table level permissioning can be specified for different groups. And finally, masking is applied to data subsets within those tables to enable column level writes to different user groups. The key to maximizing functionality is to use a data stack with a rich function library and toolset so that you would rarely need to bake your own solutions from scratch, but when that need arises, it's simple and straightforward to integrate and run any custom code. An important point to highlight here is that sufficient compute and memory resources must always be available when required by running processes. In other words, a tool may have a great function library that abstracts a complex function as a single command or step, but insufficient memory or compute resources could make the function impractical or impossible to run. A full-featured cloud-native ETL tool integrated with a leading MPP database can provide for all of this. So once again, in the context of our Moffett engagement, our stack of Matillion, Snowflake, and AWS gave us all the requisite functionality. From Matillion, all Snowflake and AWS functionality is natively accessible from Matillion functionality components. And there are also code-based components providing power users the ability to code their own functions if desired. Snowflake is a highly performant MPP database abstracted as a SQL database engine, allowing it to perform any SQL instructions. It also has a rich function library, including complex mathematical, statistical, and data parsing functions that are not typically practical in a traditional SQL database. Custom user-defined functions can also be created. AWS has a vast menu of cloud services, with new products being regularly introduced. The names or symbols of each AWS service used in Moffett's data environment can be seen here in the diagram. And then a final piece of functionality is performed on Moffett's corporate network, providing user login identity verification and gateway access control to the cloud environment, and also staging of legacy input data sets that are slated to be migrated to the cloud in the future. So usability is clearly very important. You'll want to pick a stack that can accommodate the needs and skill levels of the full range of user types. Some example user types are shown on the right. The technical skill level would generally be lower for the analysts and highest for the engineers/developers. So you may need an environment where less technically inclined analysts could easily run processes for reporting or analytical tasks. Somewhat more technical administrators can monitor scheduled processes and logs. And the most technical engineers/developers are able to efficiently create without any of the ease of use abstractions, limiting their ability to implement complex solutions. So this diagram illustrates our solution for Moffett in a way that's kind of aligned with its usability. So as you can see here, Matillion is depicted as encompassing the entire platform here because it's serving as a user-friendly front-end GUI to the entire stack. Most regular human interaction with the platform will take place on the Matillion interface. Matillion has a very intuitive user interface that really nails accommodating a diverse range of user skill levels. Snowflake has its own web-based console, which is used when setting up new Snowflake users, groups, and permissions. It's also typically where one would run the initial DDL for table creation. SQL-based run worksheets are also present in the console in the event that any ad hoc SQL querying is required. Moffett's AWS console is also web-based, but accessed infrequently, mainly for initial setup and configuration. AWS configuration may also be performed via command line. And all three of these web-based consoles are only accessible via a web browser in an authorized IP range within Moffett's VPN. So scalability is not only about providing an easy runway for expected future resource needs. You want to be optimally scaled such that compute and memory resources are provisioned dynamically moment to moment. Resource requirements may be drastically different at different times of the day, and the peaks and valleys of activity levels may be predictable or unpredictable. Pick a cloud-native ETL tool that leverages the back-end MPP database as the workhorse. That way, it can be spun up or down with different sizing according to the predictable baseload ETL needs. You'll also want to pick an MPP database that can be configured to dynamically scale up or down in reaction to real-time requests. Returning to our Moffett solution, we have our Matillion instance spinning up and down using a machine size and schedule continuously adjusted to the development schedule and timing of data processes. The AWS resources in play are all inherently scalable, and the compute capacity of Snowflake dynamically scales up to configured limits in response to current demands. There's no upper limit on storage space, either in Snowflake or the Amazon S3 data lake or landing zones. It's just charged per gigabyte month used. And as mentioned earlier in the presentation, there's a roadmap to migrate the remaining on-prem staged data sources to the cloud. So the reliance on the non-scalable resource here decreases over time. It won't increase. The general rule for easing extendability is to use modular design principles that maximize reusability via configurable parameters. If you pick an ETL tool and data stack that's already built around these principles, many benefits will accrue simply in its use, even without making intentional design choices. Nevertheless, we still want to be intentional with our design choices, and to that end, you should encourage development patterns that segment processes into a series of slightly different but mostly common child-level sub-processes. We accomplish this at Moffett by creating paint-by-number style top-level job templates in Matillion. Developers can duplicate those templates and just change the parameter values to create new processes. The top-level job pattern is a flow of modular, parameterized shared jobs. Standardized naming conventions of these jobs enable multi-level nesting of shared jobs and parameter-driven integration with the data structures in Snowflake and AWS. Everyone was very pleased with how easily extendable this platform was. The Moffett developers were building out new data transformation processes within 2 weeks of their initial introduction to Matillion and the platform. And for emphasis here, the standardization of naming conventions really drives rapid onboarding of new data sets. In Snowflake, the schema and table names followed the established convention, and there was also a metadata table and configuration tables that drove multiple Matillion processes. And in Moffett's AWS environment, our standard naming convention was applied to S3 bucket names and subkeys. Additionally, parsing and variabilization against the convention universalized our Lambda functions against any newly landed data with proper naming conventions. In other words, when brand new data appears in the S3 landing bucket with the proper naming conventions, the existing AWS Lambda process identifies the root values encoded in the file name and path, or subkeys, and calls the parameterized Matillion job passing those root values. So when it's time to onboard new data, very little new development is needed. Generally, the only new development is limited to defining any customized transformations that are needed for the new data set. And with that, I will hand it over to Carrie.
Hello, everyone. My name is Carrie Graham. I am a partner technical success manager here at Matillion. And now that Robert has piqued your interest as far as how Matillion has provided a solution in the case of Moffett, I do want to go over exactly what Matillion is. And we're going to be spending the next about half an hour getting an overview of Matillion, how it can possibly solve the different use cases and issues that you may be facing with your data pipelines. And then you're going to get an overview as far as what the actual software looks like. So as Robert had mentioned, one of the big things that is a desired end result of your data pipeline is an optimized data set. And it's great to have a tool to be able to extract data from a source, be able to place it into the cloud data warehouse that you may be utilizing. But really what we think of as what differentiates us from other tools that you may have worked with is the data transformation layer that we do provide. Hence why you see that data transformation for cloud data warehouses line that we like to put on the screen there. Let's see here. There we go. So the value of what we do is enabling faster, better business decisions in a wide variety of contexts and for a strong competitive advantage and organizational efficiency. And we do this by, firstly, enabling organizations to answer questions now instead of in weeks or months. So really giving that time to value that typically you don't see with ETL software that's out in the market right now. There's usually a ramping up period. We like to think of ourselves as something that it doesn't matter what department you may be working within. It doesn't matter what kind of skill level that you may have, whether you've been working within the data realm for decades or you maybe have working within it for the past week. This is something where you can be able to utilize the interface in order to build out that data pipeline and unlock those hidden insights found within the data. So whether you're working in a marketing department and you want that 360 customer view, or you want to be able to have timely and consistent revenue updates within finance, Matillion can be able to provide a lot of different formats as far as what this solution can look like, so that you can be able to, again, get to those insights as quickly and efficiently as possible. So, Robert did a great job of addressing the challenges that you may be facing with any sort of given data set and the solution to be able to extract and then transform it. At the very outset, you have data silos. So data is typically isolated depending on how many different sources you may be utilizing. And they're only accessible by certain groups in an organization. So you have valuable data hidden or unused for the collective value of the organization itself. And the way we try to address this is by solutioning a centralized data warehouse, by bringing together the data from all these different sources into a single destination to create a single source of truth to extract your insights from. So one of our partners that we typically work with, and you'll see exactly what this context would be, is Snowflake. And Snowflake does a great job of using or helping the users just be able to utilize the data set as it exists in the data warehouse. Many of the different types of tertiary kind of tasks, such as sizing up the warehouse, such as backing up the data, a lot of that can be completely automated through the use of the cloud data warehouse. The second challenge that I'd like to address is the variety of data. So once data is loaded into the cloud data warehouse, data from all the different source systems don't typically play well together. You may have schema drift, you may have issues with data types. Now, what we try to offer as a solution is the ability for the user to easily transform that data. And this is the backbone of what we do. It's the core functionality of our product to be able to utilize what are called components to compile SQL in the background to allow the user to then run a Matillion job and then have a easily replicatable process in order to be able to transform that data into the end product. So through transformation, we're able to reshape and restructure data into a ready-to-use format for BI tools. And with this capability, you can significantly improve the quality of your data output. The third challenge is the volume of data. So as you well know, data is being generated at a rapid pace, and it's not expected to slow down anytime soon. So if you don't have a strategy to solution that data at scale, you're at risk of outgrowing your infrastructure and being forced to continuously rebuild and maintain, wasting time, money, and resources, not to mention frustrating the folks who are actually building out and maintaining that data pipeline. So our solution there is that we are completely cloud native. We can be found within AWS, Azure, GCP, and we can address a wide spectrum of cloud data warehouses. And within those cloud data warehouses, we leverage the near infinite scale of the cloud to accommodate growth both now and down the road. The fourth challenge is limited access to data. And we've already touched upon this a little bit, but citizen data professionals, which is a relatively new term to describe people who work with data, who may not have a master's degree in software engineering, but part of their role allows them to be able to access a database, be able to write SQL queries, and be able to extract insights from that data. And these individuals are reliant on IT, which may be causing a bottleneck of requests. And the solution here is to democratize the use of data, which enables those citizen data professionals to self-serve analytics, giving back valuable time to IT and developers. Now, we talked about the issues and how Matillion is able to, at a very high level, be able to address those. But within, we consider the secret sauce to be within these 4 different points that you see here, being simplicity, speed, scale, and savings. So for simplicity, Matillion has a intuitive, easy to use graphical user interface for quick adoption and onboarding. We like to talk about our product as being completely code optional, so that for those citizen data professionals, they don't have to write a single line of code. Rather, they can utilize a drag and drop and wizard kind of interface. However, for individuals like myself who may have worked with Python or have a few years of SQL experience, they can be able to utilize their skills that they've been building up along the time in the context of Matillion. And the big proof point in regards to simplicity is DocuSign, who is a client of ours, and their data engineering team was able to become proficient in Matillion in less than 2 weeks, really providing that faster time to value. In regards to speed, we utilize a native pushdown ELT and leverage specific features to your cloud data warehouse to significantly reduce development time for a faster time to value. Also in that context, we consider ourselves to be purpose-built for that particular cloud data warehouse. In the context of Snowflake, our development teams work alongside Snowflake's development team so that we are in lockstep as features are being released. And what you end up getting are certain features such as the alter warehouse component. So a user is from within the Matillion interface able to scale up and down their Snowflake warehouse and be able to really leverage a lot of the different resources found within Snowflake. And Duo Security was able to cut their financial closure process down from 5 to 6 days to only hours, providing daily ARR forecasts versus monthly to the entire company. So yeah, again, we're going to keep hitting on that point, that time to value of being able to implement Matillion within your data pipeline. For scale, we've already talked about the purpose-built for the specific cloud data warehouse that you may be working within. And specifically, what we are doing is we're leveraging the resources of that particular cloud data warehouse. And for a lot of these different products, whether they be Redshift, whether they be BigQuery, Azure Synapse, or in this case, Snowflake, we're actually using the near infinite, not only storage, but processing layers found within those particular cloud data warehouses. And as a result, you're able to build out very complicated processes, and you're not going to suffer the quality in terms of scale. These particular types of things are able to be adapted very well in the context of a cloud data warehouse. And Clutch, a leading customer data marketing platform, was able to ingest over 20 years of retail data and transform thousands of rows of data per hour. Then finally, for savings, we're going to go into this a little bit further, but from a savings perspective, further building on the economy benefits of the cloud, you only pay for what you use. And this is a relatively new certain format within the software development realm anyways. But yes, so Matillion is billed on an hourly basis, so you're only billed according to the time that your instance is actually running. And oops. Yeah, so Travis Perkins was able to reduce their annual vendor spend by over $250,000, actually $278,000, as you can see there on the screen. Now, we're finally getting into the fun stuff with the architecture. So yeah, just to give you a little impression of exactly how Matillion sits in the context of the cloud data warehouse itself, we're going to start here on the left side and just work our way to the right. So as Robert was mentioning, there are many typically disparate data sources that are being used by a typical user who wants to be able to build out that data pipeline. Whether that's captured within an API or a database or a NoSQL database, there's lots of different formats and there's lots of different ways of accessing that data. What Matillion tries to do is to really funnel all of these different processes into a very replicable type of format so that you're not having to reinvent the wheel every single time you need to access a new source of data. So within Matillion, you are actually within the cloud data warehouse itself. So you're in the context of the cloud data warehouse itself. So as you're working in Matillion, you are connected to, I'll continue to use Snowflake as our example. And as you are developing your actual data pipeline, you're compiling native Snowflake SQL statements to then be pushed down to Snowflake to perform the actions of extracting and loading that data into your Snowflake environment. And then once the data resides in Snowflake, you are then going to be utilizing transformation jobs to, again, use Snowflake resources to put that data into the format that it needs to be. So here's the listing of the different cloud data warehouses that we work within. We also just did introduce a product for Delta Lake or Delta Lake on Databricks. So apologies, we do need to update this slide here. And once this process has taken place, once your data has been able to have a replicated job that can be run on an hourly, can be run on a daily, depends on whatever that frequency that matches up with your business use case. You can then pass that data to an analytics platform such as Tableau, Power BI, Looker. Another benefit of using these cloud data warehouses is that they play really well with other different types of applications. And as a result, there's a lot less time of beating your head against the wall, trying to figure out exactly how to make these two applications talk to each other. And as a result, here we see another logo on the screen. Citrix was able to reduce 50% of their ETL development and maintenance efforts. So again, just trying to simplify, trying to scale up your process as quickly and efficiently as possible. All right, so we've given you a lot of hot air as far as exactly what the benefits are of using Matillion. Let's see what the actual software looks like. Now, we're going to be going through a couple different contexts of Matillion. The first one will be in an orchestration job. So there are actually two different types of jobs within Matillion. The first is an orchestration. And as we were kind of referring to, Matillion is built upon this concept of ELT, and that's not a mistake. You're usually used to ETL. Rather, we are extracting and loading data directly to the cloud data warehouse prior to any transformations taking place. So that's entirely what the benefit is of utilizing an orchestration job. The other benefit of using an orchestration job is that you as a user are the orchestrator. You are the one who is defining what the business rules are, what kind of logic that we need to abide by as that data pipeline is being fulfilled. So as you can see, we've referred to it a couple times, but it is a completely graphical interface in which a user selects what we call components here from the left side, depending on whatever the step in the workflow may be, and then they can drag it as a step in their workflow. As you can see, we can designate different steps that may constitute our workflow that would be happening sequentially, or excuse me, that would be happening concurrently as opposed to sequentially. So, we could choose to have a completely, step-by-step sequential process, such as the creation of a table, loading data from S3, and then we move on, or we could have several different tasks going on at the same time. So in this screenshot that you're actually seeing here, we are looking at the Matillion ETL for Snowflake on AWS product. And it's a little bit of a mouthful, but it is really referring to the nature of this product being purpose-built for Snowflake, and it's being deployed on an EC2 instance within AWS. So on that user's particular VPC within AWS, they spin up a EC2 instance with Matillion on it. And the main benefit there is that they've not only unlocked a lot of functionality within Snowflake, but also AWS as well. So I, as a user, automatically have a connection to S3 buckets. I have a connection to whatever kind of SQS queues that I may have set up, really making that process very efficient as you're synergizing all of these different services that you may have enabled within AWS. All right. So that's a little bit of background about this actual instance. I do want to give you a little bit of a tour of the screen. As you can see in the workspace, we do give you a grid so that you're acting as a bit of an architect as you're going through your actual workflow. And each of these little icons are components, as I mentioned. And in the best way to think about them are little pods of SQL that are able to be compiled based on the arguments that I, as a user, have set within the component itself. So we take a look at this first component right here. This is something that we call the alter warehouse. And it is a perfect example of that purpose-built for Snowflake type of mindset that we went about when we developed the product in the first place. And as you can see, what we're actually doing here within the property is we're sizing up the warehouse so that we have more nodes being attributed to my actual workflow, and my data can be ingested and processed within Snowflake as quickly and efficiently as possible. And as I'm setting the arguments within the component itself, as you can see here, Matillion is validating exactly what I'm inputting into the component to tell me right then, right there, exactly where I may have turned off from entering in a valid argument. So especially when we're talking about time to value and how we're developing a job, there's a lot of ETL tools, at least that I've worked with in the past, where you spend an hour, a couple hours, writing code or putting together this whole entire process. Then you hit run, you feel really good about it, and then boom, within 5 seconds of it running, you get an error message that is pretty hard to interpret, not exactly something that is actionable. We really want to circumvent that frustrating development process so that you can validate the job right then, right there, and then be on your way as far as actually getting work done. Another note about components, you can see here that we have a connectors folder here. So Matillion at this current time has close to 90, maybe over 90, I'm not really sure, the number's constantly going up, of dedicated third-party connectors. So this is very popular platforms such as Google Analytics, such as Facebook, such as MailChimp. So certain things that customers are already using, but now they want to have an easy to use interface to connect to that platform within the context of Matillion. And through this connectors folder, you can be able to drag out those different connectors and utilize that as a source of data within a quick amount of time. Also in that context, we also have what are called generic components. And we actually have an example of 3 generic components right here. The first is, oops, sorry, I'm jumping around with the slides. The first is this load airport data. That's an S3 load component. The one right here is a database query component. So no matter what your on-prem database may be, your SQL servers, your MySQL, even if it's something more exotic, you can be able to upload a JDBC driver for your respective cloud data, or excuse me, your respective on-prem database, and utilize it as a source to be able to extract from. And we actually have an example of what that looks like right here, what a migration looks like, in which we are extracting the metadata from a SQL Server database, and then we're using what is called an iterator component to pass those table names to another component, where we're saying select all from, and we can easily pass those table names, perform a migration with very little heartache. Then at the bottom is our third example of a generic component. This is something that we call create your own connector. And the idea here is that you have any REST API that your company may use as a source of data. If you've ever utilized Postman, you can have a very Postman-like interface to build out the endpoint within Matillion, and then be able to use a component just like with the others to be able to extract that data. Anything else about orchestration jobs? As we can see up here in the upper right-hand corner, we also have error handling. So you're able to really build in business rules that, if this component were to fail, which is actually a transformation job, we can be able to roll back all changes that came as a result and generate a failure message within my AWS environment. So again, even though the interface is very simplistic and we wanted to have that very easy drag and drop kind of interface, by building in that error handling and that conditional logic, you can have a very refined, very smart kind of workflow through the use of an orchestration job. All right, and on the other side of the coin, so after you've gone ahead and loaded that data into its raw format within Snowflake, in this case, you can apply transformations via a transformation job. And as you can see, the interface is very similar. We're still dragging and dropping components. We can still link up components and given what the actual workflow may be. But as you can see, the actual category of components is a little bit more narrowed down to the actual functions related to transformation. And this is even more Snowflake or purpose-built for Snowflake kind of functionality, as everything that you will see here is able to be achieved in the context of Snowflake. So if you've ever worked with semi-structured data, we have a component that's called flatten variant, which is a very popular Snowflake function in order to flatten a JSON formatted data set into a structured data set. Also, we can perform joins, a lot like how you would be writing out a SQL statement. And another great example of why transformation jobs are a little bit different from orchestrations is the presence of the sample tab, which is not really something that you see in too many other ETL type of platforms. But one thing that you're able to do is, based on this join that I've just performed, I'm not really sure if I wrote it out correctly. I don't know if the logic is right. I performed the left join, but I don't know. You can always perform a sample of the data set, which will give you a rendering of what the output would look like. And again, you are able to validate and sample things, and Matillion is able to tell you right then, right there, if you've performed a valid operation.
Thank you for the presentation and showing us about that. And now we're gonna answer a few questions, which we have from the audience. So for anyone who didn't have a chance to ask questions, please feel free to ask them in the questions panel on the right, and we have about 3 minutes or so to answer 1 or 2 questions. So the first question that we will start with is, I'll just go in order. So Robert, this one is for you. What do you mean by data dependencies, and how do data pipelines handle them?
Sure. So data dependencies. So let's say you have a process that requires 3 different data sources, and each of those sources arrive at some point within like a 3-hour window, but you don't know ahead of time the precise times or in which order. So in a situation like that, you could create, you would have like your standardized ingestion module that is basically in charge of taking each data source as it arrives and landing it to a staged area. So you would have this module running for all 3 of those data sets on demand as they arrive. You would have one of those 3 data sets defined as the primary data set, and that primary data set, once landed, would launch a module that continuously checks for the presence of the other 2 data sets, and only once those 2 others are present would it then launch the transformation module to continue on with the transformation that requires all 3. So that's just one example. So any series of data sets that are interdependent on each other that you need to coordinate with regards to moving on to the next step.
Excellent, thank you. Our next one is also for Robert. A lot of ETL tools create pipelines that are easy to understand, but they're also inflexible. In your estimation, how dynamic can you make Matillion pipelines?
Well, with Matillion, because it does, it is so keyed on configuration parameters, you do have a very high level of flexibility with regards to setting up like one standardized job and then making that a child job of a parent job that can take parameter values from other sources. I think I mentioned in the presentation like a AWS Lambda function. So if you have like a Lambda function that's retrieving root values from, say, the file that just came in, and then passing that to your upper level Matillion function, that upper level Matillion function can basically do a wide range of things across a wide range of data sets, so long as they're all just following a standard pattern based around the rotating parameter value. So Matillion's very capable of being flexible like that.
All right, thank you. I was going to ask another Matillion question, but we'll go to a more generalized one. Robert, last one for you, and then we'll do one for Carrie. What did you mean by data dependencies, and how do pipelines handle them?
Oh,
I'm sorry, how would data pipelines manage data quality? See, I had a data quality issue. It didn't disappear.
So sure, data quality. So in terms of, okay, our modular design, we have that sort of first module that's in charge of landing the data. It takes the landed data, moves it to stage. So you could set up, so it's sort of a level 1/level 0 data quality step. That Matillion job would be defined such that if it failed to land in its staged location, and in that case, it would be like a hard technical specification failure. So data type is wrong. So it just fails to load to your staging table. You would have your Matillion job set up such that conditionally, if it fails to load, it could move that raw data to a specified like failed zone and also trigger an alert. So it could do something like call AWS like SNS or something like that. So it sends out an email or text or whatever. So that would be like your level 0, level 1 data quality check. Then you could have an actual, like more of a business defined set of data quality checks built into its own data quality module. So you could have a situation where you'd have that first ingestion module run successfully. Upon a successful completion, you'd launch your data quality module, and that module would contain business defined rules. So maybe one of your values is a string value that must belong to, say, one of 5 valid values. So you could set that up to say, if we receive a file that has anything but these 5 allowed values, it's invalid. And trigger a failure, trigger the alert, stop the process. Or it passes and move on to the transformation step. So that's kind of a general outline of how you would achieve data quality with Matillion and with data pipelines.
It's a great answer. To whom asked the question, if you need further info on data quality, please don't hesitate to reach out and we will help you with that. Last question, Carrie, this one is for you. Yes, and you did refer to Snowflake a lot, I saw, so I guess this is a very pertinent question. Is Matillion able to land data in a destination other than Snowflake, Redshift, or a cloud data warehouse?
Yes, the answer is yes. We have recently been working on output connectors, where you would be able to move data from a cloud data warehouse to another destination. So one dedicated output connector that we do have is for Salesforce. So after you've been able to move data in its raw state into Snowflake, process it, you can then move it out. But typically, if you just need to move data from on-prem database to an on-prem database, not exactly the best use case for Matillion.
All right. Well, that's about it. We've run out of time. Carrie, thank you so much. Robert, thank you so much. And thank you, everyone attending. And stay tuned for our next webinar. Take care, everyone.
Thank you, everyone.
Thanks.